Question number 19, worksheet connected particles. A smooth inclined plane of length 2.5 meters is fixed on one end on the horizontal floor and other end at the height of 0.7 meters above the floor. Particle P and Q have masses 0.5 and 0.1 kg respectively. Okay, let's show this in the figure. So if this is Q has a mass of 0.1, that means a weight of 1 Newton since weight is m times g. And P has a mass of 0.4, so it has a weight of 5 Newton, and we will be resolving its component. So in this direction, the component of weight would be 5 cos theta, and down the slope, the component of weight is going to be 5 sine theta. Theta is this angle. We can find its value. We can find sine theta and cos theta. Sine theta is 0.7 over 2.5, which simplifies to 7 over 25. And cos theta would be, if this is 7, this is 25. I'm applying Pythagoras. You can even apply Pythagoras in 0.7 and 2.5. Okay, so 25 square minus 7 square and square root of answer gives me 24. So cos theta is 25 over 24. 24 over 25, my bad. Okay. Next, there would be a tension in this direction. There would be tension in this direction. It's the same string, so value of T is going to be same on both P and Q. Then it says that particle Q is held at rest on the floor vertically below the pulley. The string is taut and P is at rest on the plane. Q is released and starts to move vertically upwards towards the pulley, and P moves down the plane. Find the tension in the string and magnitude of acceleration of the particle before Q reaches the pulley. Okay, no friction has been mentioned. That means mu is equals to 0. So we will not be entering friction in the equations. Okay, T goes upwards. So the Newton's second law on Q would be forward force minus backward force is equals to ma. Equation 1. And sorry, it's 0.1 in, not 0.7 in. Okay. And for P, it's going to be forward force would be 5 sine theta minus backward force is T is equals to M is 0.5 times A. Sine theta is 7 over 25 minus T is equals to 0.5 A. So this would become 7 over 5, which is 1.4. So 1.4 minus T is equals to 0.5a. Call this equation 2. Now solve equation 1 and equation 2 simultaneously, and we should get a equals 2 by 3 meters per second square. T is equals to 1.07 newtons. There's also normal contact force in the figure, but since there is no friction, there's no mu r component, so we did not use r in the question. Okay, next it says, at the instant just before Q reaches the pulley, the string breaks. P continues to move down the plane and reaches the floor with speed 2. Find the length of the string. Okay, so let's clear this. Okay, so Q reaches the top. So Q would be here. And because of that, this P will move downwards. It would cover a distance of 0.7 meters as well. Okay, so now P is here and this is 0.7. Okay, and they need the length of the string, and length of the string is going to be this entire length. So what I need to do, I somehow need to find this distance and then subtract it from 2.5 to get the length of the string. Okay, now how do we do that? We know that at this point, Q has a speed of 0. At this point, Q will have a speed of V that I need to find. S is 0.7 and T is also, sorry, acceleration was also found. It's 2 by 3. So I'm going to use equations of motion, find V of Q. Okay, that will be V square equals U square plus 2AS. V square equals U square plus 2AS. Then we square root this to get the value of V, which comes out to be 0.966091. Okay. Now, at this instant, right before Q hits the pulley, P will be somewhere over here, and P will also have the same final speed, which would be 0.966091, and this will become U for the final part of the journey. Okay, this becomes U, and the final speed here is 2. We know that. We need the distance of this purple region, but before we can find that, we need the acceleration of this part. Now, since the string has broken, the acceleration is going to be will be different than the acceleration of the connected particles. Okay, now we're going to find the acceleration again, and we'll use forward force minus backward force is equals to ma. Forward force is the weight, which is mg sine theta. So forward force is mg sine theta. Backward force is tension, but it's 0 now. There's no friction, so we don't need to add or subtract mu r, is equals to ma. Okay, tension is 0. I'm going to cut m and m on both sides. So 10 times sine theta was 7 over 25. This gives A. A comes out to be 2.8. So now we use this value of A here and find the distance. So we need S, we have U, we have V as well, and we have A as well. So again, we can use V square equals U square plus 2AS. Okay, we had V. V is 2. So we're going to use 2 square equals U square plus 2AS. Now make S the subject here. And you will get 0.5476, and you subtract that from 2.5 to get the length of the string, which gets us 1.95 I just have the rounded value with me. So you will write the unrounded answer and finally the rounded answer.